Question. Radioactive materials emit different types of radiation known as alpha, beta and gamma radiation. And there's your symbols, alpha, beta and gamma. Complete the table below to show the properties of these radiations. Now looking at the table, the first row is associated with the charge. So the charge compared with a proton. Remembering that a proton itself is +1. The alpha particle. The atomic number of the alpha particle is 2, the mass number is 4. The atomic number being 2 tells us that there are 2 protons in the alpha particle, so the charge of the alpha particle is +2. The beta particle. This is a high speed negatively charged particle like an electron, so it's -1. So we have +2 and -1, and you must have the plus in here. It's not just twice the charge of a proton, you must have the plus in there to show that the alpha is positive. So +2 and -1. The next row then is focused on the mass of the particle compared with the proton. We said the mass number of the alpha particle was 4, and that's already filled in the table for us. The mass of the beta particle. Now we said it's a high speed moving electron, and electrons have negligible mass compared with that of a proton. So we fill in 0 there. Gamma radiation. Gamma radiation is a form of wave, and it has 0 mass. The origin then. The origin of all 3 forms of radiation is an unstable nucleus. They all originate from the same source, which is an unstable nucleus. The nature then. Alpha is a particle, beta is a particle, gamma is a wave, or in there you could say EM radiation. Either or will get you the mark. So there's 1 mark for each box, remembering of course that if you don't have the plus in here, you don't get the mark. Part 2. State in terms of the particles which make up their nuclei. So we're interested in the nuclei. What is identical and what is different for a pair of isotopes? Isotopes have the same number of protons, as indicated by the same atomic number, but different numbers of neutrons. It's the protons and electrons that determine what the element actually is. If you change the number of protons in the nuclei, you're changing that atom to an atom of a different element or a different material. The number of neutrons simply changes the mass of the nuclei. It doesn't change its chemical performance or properties.